Okay, all right, here is the highly anticipated homework help video. I'm going to try and get this all in one video, although it might take a little longer possibly. And pardon me if it's going to be stupidly long, I will stop after the first problem and just do two videos. But I'm going to try and do this in one. All right, so the first question says, an investment of $75,000 increases at a rate of 1.25% every year. Write an exponential function that describes the value of the investment after t years. All right, so remember we have our y equals a to the 1 plus r, which is your rate change, right, to the t. So y is just going to stay y because we're writing in general equations. When it says write an exponential function that describes the value of the investment after, and they give you a nondescript number of years, they say t years, that means they're just saying write us a general equation. So you have y equals, and your a is, it's an investment of 75,000. So that's what you're starting with. So you have $75,000. That's your a. You have 1 plus your rate. It's 1.25%. So remember, if you have 1.25 and it's a percent, to turn it into a decimal, you go to the left 2 spots. So you go like that, you put a 0 in there, and then that's your point. So you're adding 1 and 0.125 together, and then it's to the t power, and then all we got to do to make sure this is completely simplified is just add up what's in our parentheses. So I have 1.0125 t, and you can always, when you add this and this, just basically just get rid of this and just kind of glue them together, right? Super easy. And then when it says what is the value of the investment after 30 years, they're giving you t, right? They're giving you t. So we're looking for y, so y is going to be $75,000, and then 1.0125 to 30 years, right? So we are going to bust into our calculator here. So we have right. So we've got 75,000, and then we're going to multiply that by our 1.0125, because that's our 1.25%. We're going to raise that 1.25, and it says after 30 years. And let's just check and make sure we got everything right. Here's 1.0125, 30. So here we go. Let's hit equals. And holy cow, look at that, right? So just by letting it sit and not doing anything, the value of that investment is $108,871, and 0.02 of a cent, but we'll just call that 108,871 on the nose. All right, so the value of this is 108,871 after 30 years. All right, so that is number one. That's what that looks like. I'm just checking, making sure I wrote it down right. Looks like I did. Okay, so $108,871. And that's typical, right? And if you think about it, that's not a great percent raise, but because it's such a large amount, it makes a big difference, right? Okay, now number 6 says the population of Algebra Town, sad place to live, is 2,000 people, right? So we're going to obviously be using our equation here. So we're just going to write this down and see if we can figure out what's what here. So I'm thinking this initial, that's probably our A, right? So A is probably 2,000. Says census data shows that the population is increasing by 14% every year. So that's my R. All right, so that's going to be 0.14. That's what we're going to use, right? 14%, so 0.14. Says how long will it take for the population to triple? All right, so for the population to triple, if it's 2,000 right now, the triple would mean to multiply it by 3, right? And so that gives you 6,000. So what they're asking us, they're saying, hey, our final population is 6,000. My initial population is 2,000. We have our 1 plus 0.14. And they said, how long? So they're asking us to find the time. So this is going to be like that last question we had on the lessons part of the video, right? Where we are going to take this and try to calculate it. So we have 1.14 to the t power times 2,000. And we want to see how long is that going to take before that 2,000 people becomes over 6,000, right? So they're giving us 6 and 7, 7 and 8, 8 and 9, 9 and 10. So we're going to go plug this in, and we're going to see, we'll start with 6, and we'll see where that's at. So let's try this. Good old algebra time, huh? So we got 2,000 times 1.14 xy to the, let's start with the low number. Oops, that didn't work. Thought there was a way to go back on this. Yep. So here, y to the 6. So that puts me at 4,300. Right. So that's 6. So we want to find it just where it's just a little more, right? Than the 6,000. So let's go 2 years more. Let's try that. So 1.14. So we tried 6. Let's try 8 years and see where that puts us. 8 years still has us a little under, so but we're really close. So I'm thinking 9 is going to be our target number. So 2,000 times 1.14 y to the 9th power, and sure enough, that puts us pretty well over 6,000. So that would be probably about halfway between during the 8th and 9th year, between the 8th and 9th year. So for our answer, we would say between 8 and 9 years, right? And we found that just by kind of testing the first one, see where it puts you, and then just kind of, take a stab at some other ones, right? Because these are telling you the values you should try. They're saying, well, you could try, you could try 6, 7, 8, 9, or 10, and plug those in for t, and see what you get. And just use a little common sense and save yourself some time, and you're in good shape. So there you go. You got between 8 and 9 years. Hope this is helpful to you guys, and luckily this video wasn't too majorly long. So glad to be able to do that. So we will see you when we see you.